firmly believe that HSMA represents the future of operational research and decision making in the NHS.
For me, it was one of the most useful things I took from it. I view it almost as a tool that I now have in my toolkit that I can use in other aspects of my work that I didn't have before.
In terms of a legacy for the organisation, I think we've really been able to demonstrate to our top team, our execs, that operational modelling has a variety of different impacts for the organisation and can actually answer some questions in a real time, but in a hypothetical way.
Operational research and data science can really transform the way in which services are delivered. We can look at the impact of placing services in different locations.
Well, a very, very good morning to you all, and welcome to our Health Service Modelling Associates Virtual Open Day 2022 for the fifth round of the HSMA programme. My name's Dan Chalk. I'm a Senior Research Fellow with the Pencord team within the NIHR Peninsula Applied Research Collaboration. And importantly for this, I am the Health Service Modelling Associates Programme Lead. And today I'm going to be talking to you about what the HSMA programme is and why I think you should be excited about it, and hopefully to get you enthused about coming along, applying for the programme and being part of what we think is a really fantastic opportunity. So this morning there's going to be a number of sessions. This opening session will be kind of introductory, talking to you about the programme and about the application process. I'll go into much more detail about the applications. Applications will launch today. They will be sent out automatically to those of you who have registered your interest this afternoon. You'll receive an application pack. I'll talk a little bit about what you need to do for that, and give you some advice on that. We're also going to hear from our PENARC director, Professor Stuart Logan, who's going to talk a little bit about why he feels the HSMA programme is so important to our organisation. Then at 10:15, we've got Tom Monks, who's our Pencord team deputy director, and he's going to be talking about something very important to both the Pencord team and also to the HSMA programme, and that is being powered by FOSS. FOSS is free and open source software, and we believe very strongly in open science and open practices. And that's very much at the heart of what we do within HSMA, and certainly at the heart of what we do within our Pencord research team. And so Tom's going to be talking about how the values, the open values of the team align with the HSMA programme. We're also delighted to have here with us today Henrietta Banks from Health Education England, who are supporting the Health Service Modelling Associates programme in this new round. And Henrietta is going to be talking a little bit about why Health Education England are supporting the programme moving forward. We'll then take a short break, and then in the second session, you'll actually have an opportunity to talk directly with some of our HSMAs. We've got 4 of our current HSMAs who very kindly donated their time today to talk to you. And so you'll be split into breakout rooms, and you'll have an opportunity to have a bit of an informal chat with them. They'll talk to you about what they're doing, and you can ask them questions about what it's like being on the HSMA programme. I'm sure they'll say lovely things, not least as I pay them. And then in the third session, you actually get a bit of a chance to have a mini taster lecture. So you'll get a bit of a feel for what it's like being part of the training on the programme. And so we're going to give you a little bit of a lecture, and you'll do a little bit of a group exercise. I basically mashed together 2 little bits from 2 of our modules, one looking at discrete event simulation, which is used for modelling pathway and queuing problems. We'll talk more about that. And one from the very first session that you'll do on the programme, looking at conceptual modelling, how you design a model and take a real world problem and turn it into something that you can put into a computer model. And so I kind of mashed together those things, and you'll have an opportunity to learn about something unique, and then have a go in your groups at designing a little model. So there's no sort of Python coding or anything today, but you will get a bit of a taster about what it's like being on the programme. Then also, for those of you who are able to stay on beyond 12:30, I will be available until 1 o'clock. If anybody has any questions that aren't answered during the course of the morning, we'll do our best to answer them as we go along, and my colleagues from the team will also be on hand to help answer any questions. But if there is anything that isn't covered, or you'd just like to speak with me directly, I will stay on until 1 o'clock. So please do stay on the call if you'd like to have a chat. So let's start. Let's talk about what the HSMA programme is. And it's basically a programme for analytical staff primarily, but not exclusively. And so we've had a number of people who've come on the programme before, such as clinicians and service improvement managers and all sorts of people who aren't necessarily working in analytical roles, but have an interest in this kind of stuff. And so although we primarily attract analysts because of the nature of what we teach and support on the course, it's not exclusive. So if you've got an interest in this stuff, then this may well be for you. But you do need to be working in some sort of health, social care or policing organisation, or related organisations such as public health or third sector organisation, whatever it may be. But if you're working somewhere in the sphere of health, social care and policing, then we can accommodate you. The only people we can't accommodate, unfortunately, at the moment, are those working in commercial organisations due to restrictions on our funding. So basically, these people are released from their usual role for a day a week for what used to be a year, but for HSMA 5 will now be 15 months. And I'll talk a little bit about why we're doing that a bit later on this morning. We've extended basically the training phase of the programme to make it a little bit less intense. And hopefully this will have a lot of benefits for you moving forward. So the programme is split into 2 phases. In the first phase, it's our training phase, phase 1. This is basically where we teach you everything we know within the team. So we sort of splurge out all this information about the stuff that we do. We teach you about the various operational research methods that we use, all the modelling, simulation, analysis methods we use, data science methods, machine learning, natural language processing, all that stuff that you also saw in the video a moment ago. We teach you basically a bit of everything that we know, and then we also dive deep into many of these areas. And because a lot of these areas require coding skills, primarily most of the things that we teach are Python based, but we do a little bit of R as well. We're not expecting people to come on the programme with coding knowledge necessarily. Some may, and that's great. But don't worry if you don't have any coding experience, or your coding experience is a bit rusty. You haven't touched a piece of coding since you playing on your Commodore 64 in the 80s. That's absolutely fine. We will teach you how to code from first principles, and then we will move into showing you primarily Python. And you've got lots and lots of practice to be able to try out these new skills, including via our new coding clubs, which I'll talk about later as well. But the real heart of the HSMA program, and something that we think makes it really unique, is that this isn't just a training program in which we teach you stuff and then you go away and you don't actually use it. You get the opportunity with HSMA to immediately apply the skills that we're teaching you to a project that has real importance for you, for your organization, for your patients, for your service users. And we provide mentoring and guidance, but these are your projects. You lead a project. And so you pitch ideas for projects that will use these new skills that you're developing in the training. And then we take a number of those forward, and then if your project's selected, you then lead on that project and apply these new skills, and you do something that will hopefully have a real impact, a real positive impact for patients or for your service users. And that's a real important aspect of the HSMA program. Another thing to say is that, and it's worth flagging up, this course we offer completely free of charge. We are funded, we've got funding to support this program, and the course is delivered entirely online, and so is available wherever you are based within England. And so there's no financial requirement. All we need is your time commitment, basically. And the organisations that have engaged with us over the years have seen that as a pretty good deal, a pretty good investment. So I keep talking about operational research and data science, and you may not be familiar with those terms, or perhaps you are, but let's just talk a little bit about what we mean by these things, particularly operational research, which I think has a terrible name. It doesn't really explain itself very well. But basically, operational research is a way in which we can use various modelling, computer simulation, analytical techniques to help inform decisions about some aspect of the operational management of an organisation. So a typical OR question might say something like, where are the delays in our emergency department processes and how do we reduce them? So it's looking at a system issue and then seeing if we can apply these kind of techniques to try and better understand what the problem is and how we might solve it. Data science, rather than starting with the system, starts with the data. And so it starts from kind of the other end of the spectrum. And it uses data-led approaches, things like artificial intelligence, various data analytical techniques, to try and generate some insight from data. So a data science question around DD might say something like, can we teach a machine to predict when an emergency department is going to breach the 4-hour target? So trying to unpick hidden clues within data to help teach a machine to learn when it can make certain predictions. So we've got a number of aims of the HSMA program as well, and I'm going to go over some of these now. All this stuff. Oh, thank you. Apology. I don't know who started the recording, but thank you. I forgot to do that. So thank you. Also, to create embedded OR and data science ambassadors, so people who can talk with their colleagues in their organizations about, this stuff's really useful and we should be doing more of it. And that's really important. To help develop and foster collaboration between health, social care and policing, that's incredibly important for the HSMA program. And a big aspect of the program is actually getting people to work together and to share ideas, both between organizations and between sectors as well. And that's a big aspect of what we do. And finally, to kind of raise awareness and promote the use of what we call FOSS-free and open source approaches. This is fundamentally important, and Tom's going to be talking a little bit more about this in a bit. But this is really important to us as a team, because the kind of stuff that we're going to be teaching you on this program, hopefully you're going to use this to go out and make a real difference to people's lives. But in the same vein, people then have a right to be able to interrogate what you've done, and to be able to ask questions about it, because it's having an impact on their life. So to ensure a level of transparency, that doesn't mean sharing patient data or anything like that, but it means that being aware of how you've built a model, the kind of assumptions that you've made, and how you've come to those kinds of conclusions. We've had some fantastic projects over the years. We set up in 2016. At the time, we had 6 HSMAs. We've now grown to getting 200 to 300 registrations of interest per year. So it's grown massively. But over that time, we've had some fantastic projects. We had a great project last year that's also a similar one running this year, looking at using natural language processing to use AI to interrogate clues in free text data and GP notes and hospital notes to see if we can work out whether there might be an imminent admission. This project was a fantastic project. We had a GP that came on the program last year. He'd done a bit of coding in the distant past, enjoyed it, hadn't done a huge amount in the interim, but was always really interested in this kind of thing. Being a GP, this was in the winter of 2020, so the first year of the pandemic, and of course the vaccinations were just coming on board. And we just taught him a little bit about Python, how to code in Python, and then how to use SymPy for discrete event simulation, modeling pathway and queuing problems. And he saw that these new skills that he developed, and he'd just been asked to set up their new vaccination clinic so they could vaccinate their population. And he saw these two things and he thought, well, why don't I just build a model? Why don't I build a model to work out if our vaccination service is going to work? And that's exactly what he did. And he built that model, he plugged in the data, and it turned out it wasn't going to work. What they planned was going to be a bit of a problem, particularly around some overcrowding issues in one of their waiting rooms. So they changed it. They changed things and they didn't have an issue. And then they ran a nice, smooth, effective vaccination service. And that was so successful that he then went on and thought, well, that was really useful for me, so maybe we should make it useful for others. So he then developed that model into a generic model of any vaccination service that people can put in the details of their own process, their own data, and he made that available free and open source online. And there's a link here, we'll share the slides after the session. You can go and play with that model now, and you can put in details of your own vaccination service. And that's a fantastic example of the sort of thing that can be done as part of this program. We've had so many projects over the years, and I'd encourage you to check out our HSMA resource website, which has lots of details about some of the projects that we've looked at over the many years. And the impact from these projects, and that's so crucial to what we do, and hopefully a driver for you embarking on this program, has been fantastic. We've had over £13 million of investment just in Devon in new mental health facilities directly as a result of the HSMA program. So we've had an HSMA project that led to a new building, and you can go and see that building. That's fantastic. New urgent and emergency care facilities across the southwest. As I say, the vaccination model that was developed last year. Crisis cafes that came up in Devon. Some of you may be aware of that if you're local. That was in part a result of a project that was done in the HSMA program. A transformation in the way that Devon and Cornwall Police have been tackling community criminal activity. So they did a little proof of concept last year where they tried out some network analysis stuff, and they basically found that they did a little test and they tried these new methods, and they tried it on an investigation that took place in a Devon town a few years back. That investigation had taken 2 to 3 months of manual investigation. Their network analysis approach that we taught came to the same conclusions, identified the same individuals who were vulnerable and at risk within 2 to 3 hours. So it was a huge sea change, and that's made a massive difference to the way they can do things moving forward. We've seen brand new modelling and data science roles and teams popping up as a result of people embarking on the programme, and huge career progression opportunities for the participants who've embarked on this, many of whom have gone on to very senior roles, including one of the new roles that was set up in Plymouth. One of our HSMAs now leading a team doing this kind of stuff. So I talked about the training program. You saw in the video at the start some of the stuff we cover. Basically, over 140 hours of training content. It's largely me, so hopefully you don't get too bored of my voice. But we try to make it fun. And 9 modules that span everything from teaching you how to code from this is a variable, all the way up to a month later, you're starting to learn about queuing problems, and then you're learning about how to build complex machine learning algorithms. So it's quite intense, but it's fun, hopefully. And the way we deliver the training is via live lectures and group exercises via Zoom. So you come along and you get a bit of lecture, and then you go off in your groups and you have a go at something, and then come back and have a look at what people have been up to, and then we learn about something else. You get support via Slack. So many of you probably have used Slack before, but we've got a dedicated HSMA Slack workspace, and you get assigned into what we call peer support groups. They're a bit like tutor groups, where and you'll work in those groups throughout the duration of the training. So you're always working together in those groups and helping each other, and working on things together. And we've even got some fun little competitions throughout the training that you do in your groups as well. And we've also got some pre-recorded content on our HSMA YouTube channel. Now, there is a little bit of a technical assessment at the end of phase 1. Don't panic about that. It is incredibly light touch, and it's basically just there just to make sure you've picked up enough basic Python, if you didn't know it already, to be able to, that we feel confident that you were able to sort of move and take a Python-based project into phase 2. That's all it is. We do try and make it fun. So last year's theme of the test was based on the 80s children's TV series Nightmare. So you may have hated the test, but you certainly enjoyed the nostalgia, hopefully. So just to give you a sense, a bit of a flavour of what these training days look like, this will give you a bit of a sense of it. So you get a sort of burst of lecture, and then you go off, do an exercise together, and then come back and learn something else, etc. And it's that kind of flow for most of the stuff. So it's all done live, and you get to ask questions, and we're around to ask questions, but you get the support of your group as well, and you get to learn together. And as I say, these peer support groups are fundamental, and something that we've had fantastic feedback when we introduced them for HSMA 3, that these were really useful ways in which people could collaborate and work together and support each other, because you can ask each other questions and help each other. We're getting so big now. I did have the idea that we should maybe have houses, but we are starting to turn a little bit into Harry Potter. Not that that's a bad thing. So once we've finished phase 1, or towards the end of phase 1, you'll begin to think about potential projects that you could then put forward to use these new fancy skills that you've got to say, well, actually, I think there's a problem over here that my organization's facing, and I reckon this thing that I've just been taught about could really help solve that. So you pitch the projects. It's not so onerous as it sounds. Basically, we've tried to make it friendly, so you basically just put together a 2-minute project video and you submit it to us. So we used to have a kind of Dragon's Den style. We sit at a long table and you present to us, and aside from the lack of wads of cash, it was very similar to that kind of thing, but that's a little bit onerous and not very practical for 100 people. So basically the idea is you put together a little pitch, say what you want to do, why you think it's important, and how you propose to do it. And then we basically have a look at them, and we take forward as many as we can. We're going to take forward 20 projects, up to 20 projects for HSMA 5. Now, it might be that your project doesn't get selected, but what we then encourage you to do is to then work on one of the projects that is selected, because there'll be such a range of stuff that there'll be something that's quite similar to what you were hoping to do anyway. And a lot of HSMAs do that. They join a sort of project that's kind of similar to what they wanted to do, and then that could help them to be thinking about this problem that they've got over here as well. Throughout the project phase, you are supported not only by one of us in Mentor. We are, I put in inverted commas, an expert in operational research and data science. We're there to share our wisdom, such as it is, in order to sort of ask you probing questions, nudge you in the right direction. But it's your project. This project belongs to you and your organization. It's your problem. You have ownership of it, and we want you to be the one that takes gets the success from the implementation of it. And so we support you, but we're there to support you and nudge you, but we're there to nurture you, really. But you also get supported by a workplace supervisor, somebody senior in your organization. It's usually a line manager, doesn't have to be, but it's somebody who's got control of your time. They're basically there to make sure that your project has legs. So if you're struggling you need to speak to, the chief exec about something, and or some consultant, and you just can't get a reply, they're there to sort of help you set up those meetings, or make sure stuff gets implemented, or to unblock things in your organization, because obviously we're external to your organization. There's only so much we can do with that kind of stuff, but also they're there to make sure that the stuff you're learning gets transferred and gets used elsewhere in the organization too. So also within phase 2, once a month, all of the HSMAs and mentors will come together for a virtual meeting. Basically, we have a bit of a chat, talk about the progress you've made, the successes and challenges you've had. So stuff that's gone well, stuff that hasn't gone so well, usually around getting data, or the data isn't quite what you thought it was or whatever. But you share ideas for how you might get around things, and exciting possibilities, and you just get to be creative and talk to each other. But you also have a bit of one-to-one time with your mentor, where you can talk in a bit more detail about your project, and you can kind of agree next steps. But the learning set meetings are really important for this kind of collaborative sharing, peer support aspect of the HSMA program, which is such a fundamental part of what we do within the program. Now, as I said, up until the current rounds, HSMA 4, we've been running a 12-month structure for the HSMA program. We've decided to change that this year, so we've extended it by 3 months. It will still start in October, but it will now run a little bit later, so it will now run until December next year. The reason we've done that is we've extended the phase 1 training a little bit. Okay, so it used to be 3 months. Now, that was fine, except it made it a little bit intense, because we'd say, well, this is we need you for a day a week for a year, apart from in November, where you'll probably be doing about 4 days a week, and you'll also be thinking about all these projects, and you'll have to take a Python test, by the way, as well, and it's a bit much. So we've decided to spread it out, so you now get a far less intensive training, where you get to gradually develop your skills, but also develop your project ideas, so you get much more breathing space for that. There's a couple of exceptions at the very start, where you've got an extra session that week, but other than that, it is basically a day a week. So if we were to express this in the form of cats, and I always like to do that, then we'd say that the HSMA 4 training was the slightly grumpy cat on the left, but you will be adopting the pose of the much more happy cat on the right. Something else we're going to also be bringing in for HSMA 5 is the idea of coding clubs. So some of you will be either new to coding, or new to coding in Python, or a bit rusty. Maybe you've done some coding many years ago, but nothing much since. So to help you learn and practice the new skills, coding skills, and also, some of the stuff we'll be showing you in discrete event simulation and machine learning and all that kind of stuff, we're going to introduce these optional coding clubs. So once a month during phase 1, you can come along, practice your coding skills. We'll all come together, and you get to do some fun stuff. And I've got some fun stuff lined up that you can have a go at to try out your new coding skills together, and hopefully that will be great, and it'll really just help you. One of the things about learning coding is you need to practice. You need to keep practicing, particularly at the start, and so it's hopefully an opportunity for you to really help develop your skills at the start there. Another big thing that we're putting in this year is patient and public involvement. Now, we've had patient and public involvement within the HSMA program before. Primarily, we've had a sort of patient representative who's helped us select which projects to take forward, which is great. But we've always wanted to do much more. And this year, we're finally going to do that. So we're actually going to be working in partnership with our patient and public involvement group within our organisation, known as PEN-PEG. And you'll basically get some patient and public involvement training as part of the training program. We'll be talking to you about why it's important to involve members of the public in health service research, and to support and encourage you to bring in patient and public involvement in your own projects via local patient groups, etc., as research partners on a project. So this is something we're quite excited about. We think there's a great potential for the patient-public voice to be a very strong one within your projects. There's also going to be new training, because apparently I just can't stop writing training sessions, so there's going to be new ones. So there's going to be a brand new addition to the geographic modelling module, where we do a bit of hands-on geographic modelling. There's going to be a new session based on something we trialled a couple of years ago, looking at the world of reinforcement learning and deep reinforcement learning, a fascinating area that's growing in popularity. I actually did my PhD in reinforcement learning, admittedly for bumblebees. I think I've upgraded to people, I'm not sure, but really fascinating area, and I think there's a lot of scope for that for health, social care and policing research. And we'll also have a series of masterclasses in phase 2. These are going to be new things. They'll basically be little optional short training sessions that will partly allow us to try out some new training, so we get to pilot a little bit on you, but it'll also allow you to sort of explore some more niche stuff that might be quite useful for some of your projects. So stuff like explainable AI or model optimization, relation extraction, and transformers in natural language processing. So stuff like, there's a bit more sort of advanced, but might be quite useful for some of you, or may just be of particular interest. We've also got something we call the Trainee Mentor Scheme. We brought this in last year. We've basically got 10 places. We've got 100 places available for the program. An additional 10 places on top of that, which are available to other operational researchers, data science scientists, and also HSMA alumni. Basically, people who've got a bit of experience doing OR and data science, not necessarily using the Python-based methods we do, because we will teach you those things. You get the same training as everybody else. But that you've got a bit of past experience in doing sort of applied modeling and data science. And you can come onto the program, you get the same training, you get to develop some new skills. You probably won't be an expert in everything, I'm certainly not. But then in phase 2, rather than lead a project as a project manager, you will support a project as a mentor. And you'll get to work on a collaborative and hopefully impactful research project with the potential for co-author publication as well. So this is something, if you're currently identify yourself as kind of an academic or a practitioner in some way, or an HSMA alumnus of operational research and data science, then I strongly advise you to consider doing this. It's a great way to work on some real world collaborative projects. For mentors, we recommend, I mean, it varies according to the project, recommend about half a day a week of mentoring time in phase 2, just to make sure you're available. It'll fluctuate depending on what the people are doing, but you need to allow about that sort of time, really, and just be available to answer questions and to support people as they're going through this. And as I say, potential for some, particularly if you're an academic, a big carrot in terms of getting some publication potential, but also just working on some really impactful work. I think should be a big carrot there. I'm not going to go into this into too much detail, but just to say, in order to undertake the program, there is quite a lot of software that you have to install. This software tends to frighten IT departments initially. Please be assured you are not alone if that happens. We have this every year. What we would advise you to do is to start asking for this kind of software early, maybe even now, even before you've gone onto the program. But I would start having those conversations and involve whoever would be your workplace supervisor, so probably your manager, to have those kind of conversations as well. We've got lots of information on our website about frequently asked questions. People often get very nervous that they're installing stuff that I think they think that they'll install it and you'll suddenly be able to take over the organization. That's not the case, and they very often have security concerns. Again, not the case, and there's a lot of misconceptions about this kind of stuff, but it's worth bearing this in mind. All of this information will be in your application packs that will get sent out hopefully this afternoon. But the main things basically you need to install the Anaconda scientific package for Python, which will install some of the IDEs that you'll be using, the R programming language via RStudio. Many of you probably have that actually these days, and some other stuff around like QGIS and stuff like that. But the main stuff is the Python stuff that you need, and then you'll basically be installing packages ad hoc, and sometimes you get a few firewall administrator issues. Again, don't panic. These sort of things often get resolved, but they can sometimes take a while to get resolved. So as well as having those conversations now, if you've got access to your own machine where you could install this kind of stuff off a work machine, it might be worth doing that as well as a bit of a backup. During the training, we'll only be using fictional data. There'll be no real patient data or anything like that. So for the first 6 months of training, you can entirely use your own machine without worry, because anybody can use this kind of stuff. It's when you get to the phase 2 where you need to do the project work that obviously you'll need to make sure by that point that it's installed on a work machine. Another thing just to flag up, so all of the Pencor team, all of the HSMA trainers, we all use Linux operating systems for various reasons, but we do know that the chance of us finding somebody using Linux in the NHS is quite low. We know most of you will be using Windows or Mac. That's fine. We accommodate for that. All of the stuff that we teach is compatible with Linux, Windows, and Mac. I mean, if you're using Windows 3.1, you might struggle a bit, but other than that, you will be supported. Another thing to flag up is that you're going to be doing some stuff that, particularly around the machine learning stuff, that really benefits from, particularly the neural network stuff, from having a CUDA-enabled NVIDIA GPU. Now, for the training, you don't need to worry about it. I mean, all of the examples we show you in the training are fairly straightforward and limited, so you wouldn't have many concerns there. And we also show you stuff like Google Colab, where you can do this stuff in the cloud as well. But if you do have a computer with access to a CUDA-enabled GPU, and there's a little link to a list of them there, then this is a good opportunity to use them, or maybe a good excuse to buy yourself one, assuming the prices ever actually come down. So I'm just going to talk very briefly, finally, about the application process. As I say, the applications will be going out, the application packs this afternoon. So if you've registered your interest, which presumably you will have, you'll get sent this automatically. We've got 100 places available for students, plus at least 10 trainee mentor places. We may be able to be flexible on that and have a few more. The applications will close on the 26th of July at midnight. And you'll be notified by the 11th of August, hopefully a bit sooner. I tend to try to do them as quick as I can. And we will let you know whether you've been successful. And then if you are successful, you will begin on the 4th of October, your very first training session. Now, if you aren't successful, please don't be too disheartened. We've got nearly 300 people that have registered their interest for this program, and that's likely to grow. But you will be placed onto a reserve list, because if anybody does then pull out before the start of the program, which does sometimes happen because things change, then you may be offered a place. So just be aware of that you might still get onto the program. And even if you don't, we'd encourage you to apply again next year too. The application pack has basically 5 parts. There is information for applicants. It's quite lengthy, but it has a lot of information in there that's really useful for you. So please read it carefully. It'll tell you all about the program and everything you need to know. Bit of a person specification to outline who we're looking for. Some of the key dates. So all of the training dates, they'll all be plugged in there, so you can see when you'll need to be available, etc. We appreciate, people will need to take annual leave and stuff like that. There'll be the odd thing you'll miss. We know that's a part of life, so don't worry too much about that. But it will give you a bit of a heads up about the sort of dates of the program. And then there's 2 application forms. You only complete one of them, depending on whether you want to be a student or a mentor, and they are slightly different. If you're applying to be a student, you need to be based or partly based in some kind of non-commercial health, social care, or policing organisation, or as I say, something related like public health, third sector, as long as it's something in those lines. You must be based in England. This is a requirement of our funder, and you need to be working either in an analytical role, or you can demonstrate some prior experience or skills or interest in analysis or computing or mathematics. So you might be a GP, but you did a bit of coding in the past or something like that. Okay, something you can sort of pin there. You need to have full organizational support. Your organization is, this is a big commitment. You're committing to a 15-month program at a day a week of your time. Now, most organizations will see that there's a great investment, and many have, but just make sure that they do back you. And you can't have undertaken the HSMA program previously. You might have applied, but you mustn't have actually taken the program previously. To be a mentor, you need to be some sort of existing academic practitioner or HSMA alumnus in OR or data science, but you are not restricted to England. Because these are additional places that increase our mentoring capacity, you don't need to be restricted to England. You need to be able to commit to the training though, and about 10% of your time, as I say, for mentoring. And again, you need to have full organizational support behind you too. What are we looking for? Really, the key thing we're looking for from both students and mentors is enthusiasm. That's the big thing. You're genuinely interested in this kind of stuff. That's what we're looking for. We can teach you these kind of skills, and we can work with you, but you need to have an interest in it. That's going to be the most important thing. Otherwise, you're going to get bored as well, because there's a lot of stuff. So you need to be happy to learn and apply skills. You need to probably think a little bit creatively. That's quite important for model building. You need to be somebody who would be comfortable, even if you haven't done it before, and with the caveat that you would get mentoring support to manage a project, and be able to go into the project phase, that you'll be meeting with stakeholders, etc., all that kind of stuff. And really, you should be people who want to make a difference by doing some applied research. That should be a sort of big motivator for you. If you're a mentor, again, the enthusiasm is fundamentally important. And again, you should be wanting to learn lots of new skills, but you also particularly want to support others to be able to do this as well. So I'm not going to go through this in detail, but you'll see in the application form, there's a number of sections. We've tried to make it as straightforward as possible, so it's not too onerous. There's a few tick boxes at the start, which just checks your eligibility. Some technical skills where you can just give some examples of stuff. You don't need to be experts in everything, just to give some examples so we've got a sense about what sort of technical skills you've got. And I say one of the things they'll ask about is coding. Don't worry if you haven't got any coding experience, that's fine too. You'll then be asked a couple of problems, a couple of scenarios will be presented to you. We're not necessarily looking for a right answer. There may not even be one in these. We're just trying to get a bit of your understanding about how you're thinking about some of these kind of problems that you might be tackling within the program. But probably the most important section on the form is the applicant statement. Why do you want to apply for this program? What is it that attracts you to it? And why do you think you'll be good for the program? And then a bit of organizational support as well. You do have to put down the details of whoever is going to be your workplace supervisor, your line manager, or your whoever the other senior member of the organization will be. Please do check with them first. You have to essentially sign off on their behalf, and they will get notified that you have either been accepted onto the program or not. The last section is the matched funding section. This can often confuse people. Please don't worry, it's not actual funding, it's not real money. Basically, as part of our reporting process, we have to report where people of partner organisations, that's people in the NHS and police, who are donating part of their time. We want to quantify that time in terms of what the real world sort of money equivalent would be, so we can claim that as matched funding. We can say, well, look, this organisation gave us £2,000 worth of time this month, or whatever. And that, although no actual money changes hands, it's really important for us for funding. So we just need a consent that we can use your time in that way, and it'll explain that in more detail on the form. Similar for the mentor form, but obviously it's why you want to be a mentor, and you don't need to answer the problem assessments. Another thing to flag up, on the 28th of September, there'll be a virtual event at which our current HSMA, so round 4, are going to present their projects. This is a great, particularly if you're embarking on the program, this is a great way to find out more about their work and what they do on the program. So please do come along to that. If you've signed up when you register your interest, if you said that you also want to be added to the Pencord mailing list, you'll get notified about it. If not, you can either join the mailing list, or you can keep an eye on our Twitter channels down here, Pencord UOE and Peninsula Arc, nearer the time. But 28th of September, hold that in your calendars, because it's a great opportunity to hear about what the current HSMAs are up to. So I'm going to stop talking there. I've overrun very slightly. But just to say, this website here, this is our new HSMA resource website. This is your friend for this kind of stuff. It's got lots of useful information, including frequently asked questions, lots of information that you can give to any concerned IT departments or managers, etc. as well. So do check that out. All of our stuff is free and open source as well. So you can view our past HSMA lectures and get a bit of a flavour for them on our YouTube channel, and also the materials are available on our GitHub organisation as well. But obviously the real value of coming onto the HSMA programme, hopefully, is that you get to work with us live, and you get to undertake a project, a real impactful project, and we get to support you to do that. Okay, at this point, I'm just going to ask, just stop for a couple of minutes, just to ask if there are any questions, comments, or interjections. We probably won't be able to get through all the questions. As I say, there will be an opportunity to stay on at 12:30, or we will. You can ask after the session, or if there are any questions we don't get to in the chat, I will happily send out responses afterwards. If I can just ask my colleagues, Tom, Alison, Kath, are there any sort of pressing questions at this stage?
Dan, people have been answering questions in the chat as we go. I'm just trying to disentangle which ones haven't been answered yet.
Okay, that's fine. In which case, it might be better for me to have a look in a bit. And I'd say if anybody's got anything pressing that they do want to speak to me about today, if you can stay on at 12:30, I will happily sort of have a chat with you about it as well. But hopefully, yeah, we're answering them. My colleagues, my glamorous assistants, are answering them as we speak, and answering your concerns. My overall comment would be, if you're in doubt, apply. I mean, I think this is a great thing. If this sounds interesting to you, go for it. Okay, and we will try and support you as best we can. Okay, at this point, I'm going to just hand over to our PenArc director, Stuart Logan, who's just going to talk a little bit about HSMA and why it's important to the organisation. I'm hoping Stuart's here, actually. I have no idea who's here.
Yep, I'm here.
Fantastic. Thanks, Stuart.
Hi, everybody. Listen, I'm going to talk for a very short amount of time. So I don't know what a CUDA-enabled GPU is, and probably never will. So as you'll gather, I'm definitely not a modeler. I'm definitely not a mathematician. I'm a pediatrician who fell accidentally into epidemiology and research, and did so because I spent a lot of my time not knowing what the heck to do with my patients. And actually, the ARCs and the clerks before them are a direct answer to that problem. So they grew out of a commission of inquiry in 2008, which was looking at why is it that the NHS, in this case, isn't as good as it could be in making really sensible use of evidence and research. And there's huge discussion about this thing they kept talking about, the research practice gap. And I'm sure everybody here will have heard the standard thing, which is people say it takes on average 17 years between getting a piece of research clear and this really getting stuck into widespread practice. Of course, we know that that's a bit simplistic and it's a bit more complicated and so on, but certainly there is a big gap. But many of us think that the problem isn't the research practice gap so much as the practice research gap. And what we've been trying to do in the ARCs is to look at the practice research gap and how we can work on it. In other words, I'm a clinician. I'm interested in what happens to patients. And what I want to be able to do is to be able to look at where the problems are and then say, how do we mobilize evidence? How do we mobilize research to try and make things better in the service? So one of the things, when we first set up the clerk, we had a tiny little group led by Martin Pitt who were doing a little bit of operational research modeling. And to be frank, I had no idea what it was about or what it meant. But it soon became clear that this was one of the most effective ways we could get of working with people in services to work out what the difficulty was, and then mobilizing this powerful tool as a way of improving services. And it's just snowballed. It's been one of the most successful bits of the work we've done over the last 15 years. And clearly, the great thing we've been enabled to do now is to take this extraordinary capacity building program, which Dan and the crew have set up, and with backing from Health Education England, actually open this out and make it a national program. So it's so clearly in the spirit of what we're trying to do, because we've seen directly how the work that the group have done and the work that HSMAs have done have actually transformed local services. Finally, I'll just say, I think what's been particularly exciting for me is watching how we've moved from a very narrow health service focus to involving people from the police services and into social care and so on, because it's pretty obvious that all of us are interacting and working together. So I'm going to shut up, but as to say, it's a fantastic program. We love it. And I can score lots of brownie points by going to big international meetings and saying, we've done this incredibly clever thing, even though I don't really understand what it is they've done, but I understand what the impact is. So thank you very much. And I hope you'll all want to come and play with a team who are great fun to play with.
Brilliant. Thanks, Stuart. Thanks very much. You're always very welcome to continue talking when you're saying how wonderful it is. So that's fine. Okay, so I'm going to hand over now to our Pencord Deputy Director, Tom Monks, who's going to be talking a little bit about FOSS and what the FOSS is about.
Thanks, Dan. Let me just share my desktop. So hopefully people can see those slides. Can you see that, Dan?
Yeah, that's coming through.
Excellent. Okay. Well, thank you very much, and it's great to be here, and it's great to see so many people with interest in this next iteration of HSMA. So I'm going to talk very briefly about FOSS and why that is important to me, and why it is important to the Pencord Research Group, and so it's why we underpin HSMA in FOSS. So by FOSS, all I mean is free and open source software, just to be absolutely clear, if you're wondering what I keep meaning when I keep saying FOSS. So I'll start off by describing FOSS from kind of a technical point of view. And we do that using the 4 freedoms. So free and open source software gives you these 4 freedoms, like the freedom to run the program as you wish for any purpose, the freedom to study how the program works and change it so that it does your computing as you wish. So that kind of makes sense when you think about open source software. So it's code that you can see, and that might be available on the internet. It might be a download that you can get, or it might be through version control software such as GitHub. So those 2 freedoms are typically what people think about when they think about open source software. But we get into some good stuff with freedoms 3 and 4. So we have the freedom to redistribute copies so that you can help your neighbor. And this is the one I really like, and I'll give you a little story in a moment about why I like that freedom. So it is licensed in a way that allows you to share copies of your software with other people, and they can go on in turn to share it with others. So the freedom to distribute copies of your modified versions to others. So people can take your software, they can modify it, and they can share that on. And that allows the community to benefit from your changes. So why is that important for Pencord? Well, it's really important for us because of this thing called open science. So this is kind of confusing. If you're not a scientist, I often think this is a really confusing concept. So much of science is closed. So we think about the scientific process as a discovery of new knowledge and then sharing that knowledge. However, that knowledge is shared through a medium which is often problematic, which is research papers. So research papers are using human words, they can be vague, and we've tried various things over the years to try and improve the quality of papers to communicate how things were done, the methods of how things were done. And there's been various ways of doing that. There's been reporting guidelines written, so like a checklist of the things you need to go through. But what we've really found is that really falls over when you get to data science. And that's because data science is so complex. So what we found in Pencord is that free and open source software is very much the way to go to make our science open, to make it shareable and usable by others. To give you a little example of that, about 8 years ago, I published a paper about stroke care, and it was a model that, in theory, anyone else could use to model their stroke pathway, to look at how much capacity you would need in rehabilitation, how much capacity you would need in the acute part. Could you bring those 2 together and do some flexing of the system? So a pretty simple discrete event simulation model. So I was approached, after I published that, I was approached by commissioners in 2 other parts of the country, and they wanted to use that model, which was great because, you know, we wanted to share the work, the paper was available, and actually we made the model available as well. However, we'd not used free and open source software for that project. We'd used commercial software for the simulation. So that basically stopped that work being used in another part of the country. And the reason for that was there was a hefty price tag attached to the software. And we're talking thousands of pounds to buy the software, plus thousands of pounds per year for maintenance of that commercial license. So that was a real eye-opener for me at that stage in my career, that actually I couldn't continue using commercial software if I wanted my research and my models to be used by other parts of the NHS. So now, when we're recruiting people into Pencord, we're really looking for people with some experience of free and open source software. So to give you a flavour of some of the basic or basic and essential technical skills we look for people in Pencord, and these are some of the things we teach in HSMA. We're really looking for them to be able to program in at least one FOSS language. So that might be R, which I know is very popular in the NHS through the NHS-R network. Python, now a lot of our work is in Python. It's the world's most popular programming language. So we're often looking for people with those skills because Python is so integrated with data science now. And the new one on the block is Julia. Julia is very similar in style to Python, hasn't quite got the ecosystem behind it that Python and R has at the moment, but it's much faster computational. So some of the simulation work and the big optimization work that we're doing, Julia is a massive thing for the future. And we're looking for people who can, have experience of sharing their work and managing it in a sensible way. So we look for people who can use version control of some description. So there's a particular piece of version control we use in Pencord called Git, and that integrates with cloud-based version control, a way that I'll show you in a moment for sharing code on the web. So we use GitHub a lot, but there's also a kind of a different competitor to that called GitLab that we sometimes use as well. And then lastly, now people often don't come into Pencord with these skills. We provide some training and support to move over to this. We work primarily through Linux. So we don't use Windows within Pencord. We all do this through Linux, and that's because Linux is a free and open source operating system. And that allows our models, our software environments that we use for our modeling to be shared exactly. And that helps us with a thing called reproducibility, which is very much a part of open science. That's the ability to exactly recreate the conditions that we had when we did our modeling. So I'll just finish up with how Pencord works with FOSS. So a few examples here. So we've got one here where we just include the links to source code with our publications. So Alison's in the chat. So this is a recent paper by Alison and some authors co-authors from Bristol, optimizing the balance of acute and intermediate care capacity for complex discharge pathways. So click on that. Accept all cookies, and that opens a journal article. So this is a bit like the straight pathway work that I described earlier. So you get a journal article, which is kind of the currency of academia. It's what we need to produce. But nowadays, what you tend to get is a sort of description of the model, and then you get a link within the paper that takes you to, in this case, it takes you to GitHub, and that takes you to the source code, and that is all the code that was written that produces the results of the study. So that's a kind of basic level. That's like the lowest level sort of thing we do in Pencord for getting our work shared. But we can go even further nowadays. We can produce publication quality code, and we can output that in what's called a Jupyter book. So one of our big projects is around stroke audit data and applying machine learning work to that. And that's a hugely complicated piece of work that we could never really communicate in a report or in a paper. So what we can do is we can produce effectively websites, and those websites mix both text, so we've got here a kind of explanation of the project and the aims and summary of the project, but also code. So we can, for example, go to our logistic regression code, and we've got actually a Jupyter notebook built into this website that mixes text that describes the aims of the notebook and also the Python code that we've used to create it. So we can exactly show people how we produce the results that we've included in the paper and annotate that and package that all up very nicely within a website. And we can do some exciting stuff as well. And people on HSMA have gone on and produced executable models. So models that people can run online without any installation. So we've used BinderHub for that, and we've also used Google Colab. So an example here that was written by Dan is a model to do with end-of-life care that Dan produced during the early part of the COVID-19 pandemic. So again, you can see it's a bit like that Jupyter book. So we've got text here describing how things work, but now we've got, this isn't a website, this is live code. We can actually edit this code and we can run this code through the internet without any installation. There still might be issues, of course, with any organization. For example, your organization may block these websites. However, it does mean that you don't need local installation on your own computer. And that's a great way for Pencord and for HSMA projects to share their work. And then we can gradually crank up the levels of sharing our work. So we can go and use something called Docker. And that enables us to package up the exact software environment that we used for our work and share that with others. So for example, here we've got a project forecasting ambulance demand. And if you click on that link, that takes you to Docker Hub. So Docker Hub is similar to GitHub, which kind of version controls software, but Docker Hub has the whole shebang. It has the whole software environment. So all you need to do is have Docker installed on your computer, and then you can pull what's called a container down from Docker, and you can open that container, and that contains all of the code that was used to produce this paper. So we've got a link to the paper here and a link to the source code, but all of it's packaged up within this in a Linux environment. So you can run Linux on your own computer through Docker, and it will just reproduce all of the results within that paper. So you can check everything works, you can take the code, manipulate it and use it in your own way if you choose to. So there's various levels of sophistication we can go to now using FOSS tools to share our work. And this very much underpins what Dan and others will teach you within HSMA. So that's me, Dan. That's everything from me. Just to say that these slides are available. I'll pop them in the chat, the link in the chat, so you can click on those links that I showed you then and have a bit of a better look if you wish. Okay, hopefully I didn't overrun too badly there, Dan.
No, that's fine, Tom. You did, but so did I. So who am I to judge is my motto. So that's absolutely fine. No, thank you, Tom. I think that was really useful it's such an important part of what we do, and therefore, what we do in the team, but also what we teach within HSMA, that I think is really important for people to understand that. So no, thank you very much. So lastly, I'm just going to, before we go to a short break and then talk to go to the next session, I'm just going to bring on Henrietta from Health Education England. Hopefully you're here, Henrietta. Again, I can't see the participants. Just to talk a little bit about why Health Education England are supporting this latest round of the programme.
Thanks, Dan. So I'm going to try and share my screen. I thought it's good to just visualize why we are interested in supporting the program. So hopefully I can get my slides up, and I think I can. There we go. So please tell me if you can see.
Yeah, that's come through okay.
It's perfect. Let's close this, and then yeah. Okay. So I did introduce myself in the chat. I am Henrietta Mbibankas. I'm head of blended learning, but I also lead on digital learning and development at Health Education England. Happens to be one of the clinical entrepreneurs. So why is HE interested in supporting this project? If I can actually move the slides. Yeah. So I think for our starting point is the fact that we do need data analysts amongst our NHS workforce. As you can see, data and information in terms of application side, looking at the list on your right, you can see data analyst and health data analyst as an area that we absolutely need workforce in. But also, if you look at the chart on the left, it's, you know, we haven't actually got the workforce we need. So we need to recruit a lot more or attract a lot more than we have. So what is HE doing overall in the digital digital learning and development space? So this is a busy slide, but I'm not going to go through all of it. We are looking at not just attracting and training people in health and healthcare, but also how do we support digital specialists into the health workforce. So I'm just going to focus on the specialist box, which is a bit of a mustardy brown color, and you will see that HSMA is listed there. So I think for us, this is a really good partnership to have, to be able to really support the development of our analyst workforce. So that specialist workforce that we absolutely need. And as much as the Topo review has highlighted within health, to be able to do that. Now, you may be asking why specifically this, because there are lots and lots of, you know, analyst training out there. The reason for this is because we feel that it's unique. So whilst there are some analysts training out there, this is unique in the sense that not only does it bring health and social care together, but policing. I think really having that, I think in health, we are always in the danger of just looking, you know, at our patch, but actually having policing there, bringing health and social care together, which is again something we rarely do, but actually makes significant impact. We really are keen on this because of that uniqueness that brings up that multi-professional element to it, but also that national offering. So whilst this program has been going for a few years, for us, this is exciting because now it's not just going to be accessible by certain areas, but actually nationally people can access the program. But let's not forget the impacts that the program has made and hopefully will continue to make as we widen it up nationally. It's supported the development of new services, and these are multi-million-pound services. So again, for us, this is key. We're investing in something that shows impact, something that shows value for service delivery. Again, processes is changed processes, but also forming teams that wouldn't have been there previously. So I think 5 minutes was the time given. I'm not going to go into lots of slides. Really, it's just to say that we are very excited as an organization to really be working with Dan and colleagues to really get this on the road, and hopefully we'll be seeing a lot of you applying to it and supporting, you know, the data analyst workforce within our healthcare settings. So just really finishing by saying thank you to Dan and colleagues, and for all the hard work and for the impact that is being made or has been made and hopefully will continue to be made. If anybody wants more information about Health Education England's work, you can either follow us on Twitter or check our website out in terms of all the work that we are doing in the digital learning and development space. So I'll stop here, and thanks for having me.
Brilliant. Thank you very much, Henrietta, and we're very much looking forward to working with Health Education England as well. I think it's a fantastic opportunity to really, as you say, grow out this program and increase the level of impact and to really grow it. There's one thing's being very clear that there's huge levels of interest in this, and you know, we want to do all we can to try and bring as many people onto this as possible, and also to continue generating the fantastic impact stories that have been so important as part of this program. So what we're going to do, I'm just one thing I've just been flagged up, reminded by one of my colleagues. If you are interested in working with us, we do actually have a job available. I'm going to post in the chat a link to the job. You do need a PhD, but if anybody here is interested in working with us, specifically working with us to support the HSMA program, we're building up a little team. We've got some fantastic new people coming on board already, but if you are interested, then please do check out that link too, if you'd like to work with us even more. Okay, so I think we've overrun very slightly. So what I'm going to suggest we do, so for this next session, you're basically going to split up into breakout rooms, and you'll get a chance. We've got some of our existing HSMAs with us right now. Basically, go and have a chat with them. So I'm going to suggest that we do that for the next half an hour. I'm going to open up the breakout rooms. Do take obviously 5 minutes to stretch your legs, but I'll leave it open as to when you do that. I will need to go now because I could quite do running to the loo, but I will open up the breakout rooms. What will happen then, we'll run until about 11:15, maybe just after, and then at that point I'll bring everyone back into the main room, pull you all back, and we'll have a little bit of a mini lecture, which hopefully will be fun, and you'll get a bit of a hands-on taster of HSMA. So for the next half an hour, I'll open up the breakout rooms. You'll be able to go in and choose which breakout rooms, so dip in and out of them, and have a chat with the HSMAs who have kindly given their time today to come along. So we've got 4 of them, 4 different breakout rooms, and they'll talk to you about their work. If you've got any questions about the program, then please do ask them as well, and I'll be floating around at various points. Okay, I will open up the breakout rooms, go and stretch your legs, and I will see you all back here at 11:15 for a bit of a lecture. Hi everyone. Okay, I think you should all be back in the room now. So first of all, thank you to our 4 HSMAs who took the time to come along today and share their experience of being on the program. I managed to dip into all of the rooms briefly to hear the conversation. So it's hopefully you all found that useful as well, to be able to get a chance to speak to them. I promise I didn't pay them anything, particularly if they're saying anything nice. But hopefully it's given you a bit more of a sort of first-hand flavour of what it's like being on the programme and involved in that. So again, I'm aware there are various questions that remain unanswered. We will make sure that any unanswered questions today, either you can stay on after, or we will circulate answers to any questions I didn't get around to today as well. But as I say, if you're in doubt, if you're interested in this stuff, then apply, and I think you'll have fun. I think you'll have a good chance. I did see a question as well that come up about whether we could increase the number of places available to 200. We'd absolutely love to do that, and something that we do want to do in time, grow the program. And what we're trying to do at the moment, obviously we need essentially funding to support the program. So as we're getting that funding in, we are growing the team. The team at the moment that runs the HSMA program is me, and I'm going gradually grey as I teach more and more. So I do need a bit of help. We've got somebody coming on board in September, fantastic chap that's coming on board, and as I say, we're recruiting again. So as we gradually build up the team, the idea is that we will then hopefully grow the capacity of the program to meet the demand, because absolutely we'd love to do that, and we want to be able to support as many people as possible on this program. Okay, so for this last section of this morning, so you've had a bit of a introduction to what HSMA is, and the application process and what it means, what it involves, and a bit of detail about that and why it's so important for us and hopefully for you as well. And you've had a bit of a chance to talk with some of our just a few of our current HSMAs about their experience. So we thought it'd be really nice to give you a bit of a flavour of HSMA training. So we're going to give you a little sort of mini lecture, and as I say, this basically smashes together a couple of small sections from a couple of the HSMA training sessions, but it is a kind of standalone thing in itself. So hopefully this will be useful for you moving forward as well. So I'm just going to share my screen. This will work. Brilliant. So what we're going to be talking about is something called discrete event simulation. Now, you're not going to actually do any Python coding, so that would be ambitious, I think, particularly if you've never done any coding before, or even any Python coding, to try and teach you in about 30 minutes how to build something like this. But I just wanted to very briefly show you the sort of thing that you're going to be building in this course. And this is one of the things that you'll learn fairly early on in the course is a package in Python known as SymPy. It's a free and open source package that allows you to build discrete event simulation problems. I'm going to talk more in a minute about what those kinds of problems are, but they're basically kind of queuing pathway type problems. So this is actually a model that we show you at the start of the course that just takes a very simple fictitious system where people come in and to an ED, and they get registered at the desk, and they get triaged, and then they get treated, and they might go over to the treatment cubicle or to the ACU or whatever. Now you actually build one of these models. In fact, you'll build something even more complex than this quite early on in the course. Now you might be looking at this and thinking, there's no way I'll do that. Trust me, you will. It's not as bad as it looks. But what we can do with this kind of model is that we can run it, and we can see what inputs, what outputs are generated. So here we've got, for example, that we've got a receptionist, we've got 2 triage nurses, and we've got 4 treatment cubicles, and then we can put in data about the average inter-arrival times and registration times, etc. And it'll run a simulation of that model, and it'll spew out predictions about how long people are waiting in various parts of the system, and we can run that, and then we can do things called what if analysis, where we say, well, what if we were to play around? What if we put in an extra nurse? What if we took away a treatment cubicle? What do we think the impact's going to be? And we can play around with that kind of thing. So this is what you'll get to play with on the course, one of the many things, and these are fantastic models that you can play with. But we're not going to go into the Python details this morning. Instead, I'm going to talk you through some of the principles behind both discrete event simulation and also conceptual modeling, which is a really important aspect when you're doing any model building, regardless of what type, to be thinking about how you go about moving from a real world problem to a design for a model. So we've called the session QQ Barney McGrew, and you'll get used to various puns for each session throughout the HSMA training. It's just one of the things that gives us a bit of character. Now, to say you will be able to download a copy of these slides. So I'm going to give you about 25-30 minutes of lecture, and then you're going to work in some groups, and you're going to have a go at a fun exercise. Which for that exercise you may want to refer to the slides. So when we get to that bit, and I'll put this link in the chat as well when it comes to that bit, you'll be able to download the slides, or you can even view them directly on GitHub, and you'll be able to refer back to anything. But we're not going to ask you to do anything too complex, so don't worry too much about it. So we talked about what operational research is earlier on. We said it's a way in which we can use computer modeling, simulation, analytical techniques to inform decisions about the operational management of an organization, and in some way, hopefully, improve decision making. And a key aspect of operational research is this thing that I mentioned earlier a couple of times called what if analysis. So if we imagine our system that we're trying to model, now we may have what we call a base case scenario, and a base case scenario is basically a model of the system as it stands right now. Okay, so we create a model in our computer, a little computer version of our real world system, and we can use that to see how well the system is currently working and get a sort of an overview about what's happening within our system, look to see where the bottlenecks might be, for example. So we could use that to think, to explore how long patients are spending in the system now, where are the delays, and what that information, by building that model and getting that overview of it, might provide us with some clues about where we might need to fix things, because we might see, oh, there seems to be a bit of a bottleneck around this part of the system, so maybe we need to look at that, and maybe we need to try things that might alleviate that bottleneck, because it could help us improve our system. So to do that, we use something called what if analysis. And what if analysis is basically where we take the model that we've built of our current system, and we adapt it in some way to reflect various possible future scenarios. So what might happen if we were to change this or to change that. So play around with the system in a safe way in our computer model, And based on the data we've got, we can then essentially make some predictions about what might happen if we were to do these things. And that information can then be used to help decision makers make more informed decisions about what decisions they might take. Because they might say, well, actually, we don't think the model isn't predicting that doing this thing over here, adding the cubicles over here, isn't really going to do much. But we think that actually doing this over here, adding the resource over here, might help a lot. And so they're not crystal balls, and they can't, you know, they're not designed to accurately predict what's going to happen, but they can give you a flavor about the sort of thing that might happen if you were to adopt various strategies. So why do modeling? Well, there's a number of sort of key benefits to modeling as an approach. The first one is what we call emulation. So if we build a model, we're essentially creating a version of reality that we can play around with without any risk or consequence. So particularly in health, what you don't want to be doing is coming in the morning and saying, do you know what? I reckon we can do without a nurse, and then just sending the nurse off and saying, let's just see what happens. And then a disaster emerges, and you say, oh, we lost quite a few people doing that. We probably shouldn't have done that. That's not the sort of thing you want to be doing. So actually, by building a model building a computer model, for example, where you can play around with these things, you can find out what might be a good idea and what might be a bad idea without actually trying it out in real life first. So there's a bit of a sort of safer way to play around with things. But there's also, related to that, there's the benefit of speed, in that actually these models, and you may not think it at the moment, but you can actually build these models very quickly once you get used to doing this kind of stuff, and certainly much more quickly than in reality you could affect the real world changes. It's much quicker very often to build these models, build a quick and dirty model, grab some data that you've got, plug it in, get a feel for what might happen, than to go through the process of having to make that real world change, particularly if you then got to reverse it because actually it's a catastrophe. Models can also have a side benefit of the benefit of communication. Because models can really help you to communicate about a problem, to help people talk about a system using a shared language, because they can all look at their system that they're working within and talk about it in terms of the model, use the model as that kind of frame of reference to talk about potential changes and what's going wrong and where things could be improved. And related to that is this idea of systems thinking. Just the very process of getting people to think about a system in a systems kind of way is actually really beneficial and can affect change in itself. Because very often people, understandably, will be working in their bit of the system and they're not really that worried. They haven't got time to be worried about what's happening over here. So they don't tend to have that system level thinking. But the process of building a model and trying to build a design for a model just gets people to start thinking about the thing they're working in as a system. And that can be really important in itself. And we've seen time and time again over the years where we've done projects with people that just going through the process of mapping out what's actually happening can spark off ideas about what they could do and say, oh, I didn't realize that was happening. That we shouldn't be doing that. We could do this instead. Sometimes you don't even need to get to the model in some cases. And there's a fifth benefit, and that's one of objectivity, because obviously, you know, a lot of these debates about what should happen, very often they're sort of politically charged, or people may have very strong feelings about what should and shouldn't happen. And a model can provide some objective support for an argument, because it can provide, say, well, this is the data we've got. And if we plug that in, this is what the model is saying. Now, there is a big caveat to that, that this does assume that the model has been built objectively. You can create a model to say anything you like. So you need to be very mindful of that and to make sure that the model has been built in an objective way. But assuming it has, then absolutely that can provide objective support to help a decision maker to come to a decision. So in operational research, and particularly for discrete event simulation, we often go through what's known as the modelling cycle. And this is something that your HSMA projects that you will go through. Basically this it's a kind of cycle here where we start with some kind of real world problem. We then in some way try to translate that into a conceptual model, a kind of blueprint, a design for what the computer model might look like. Okay. And then we move from that into a formal model. So we take our blueprint for our model, turn that into a piece of Python code, say maybe we've built something in SymPy. And then from that formal model, we can generate some outputs to hopefully provide evidence that can inform the decision makers and hopefully resolve this problem situation. This is by no means a linear process. And you will be going back and forth along this, trying to work out, have we, particularly in this bit, where you're trying to work out, have we adequately captured the aspects of the real world? And we'll talk a little bit more about that this morning. And even here, have we captured everything in our Python model that we said we would in our design, etc., etc. So at every stage, it's a very iterative process that you're going back and you're talking with the domain experts, the people that are working in the system, to get a real sense about how this thing works so that you can adequately represent it as a model. So this morning, we're going to be focusing on this bit, which is moving from the real world problem to the conceptual model, the conceptual modeling process. So one of the things you need to think about when you're trying to take a real world problem and trying to work out how you design a model that will try and hopefully solve that problem, one of the key things you need to think about is, well, what are you trying to achieve? What's the objective of the model? Very specifically, why are you building this? Okay, so there's some things that you can think about to help you in that process. The first is to have a problem statement. What is very specifically the problem that you are trying to solve? This model shouldn't be trying to solve everything. What is the specific issue that's trying to be solved? So it might be, there are significant delays in referral to treatment. That might be your problem that hopefully your model is going to try and help solve. You also want to identify what your what if questions are. Remember, that's the power of doing this kind of modeling, is that you can ask those what if questions and try out various scenarios. So, you might say, well, one of your what if questions might be, what if we reorganize the testing priority? Can we test that in our model and see what help that might be to this problem? You also have to think about what deliverables to be, what's going to come out the other side of this. In some cases it might be that you're building an ongoing use tool, but in most cases you'll probably be doing a kind of disposable model. And a lot of our work traditionally has been this, where you build a model, a relatively simple model that is designed to answer a particular question, that is then used to inform a decision, and then essentially the model's not thrown away. We share the models so that other people can benefit from that. But it's kind of a one-use model for that particular problem. So it might be that actually the deliverable is a report that outlines results, but as Tom was talking about earlier in Open Science, we always try to provide the model as well. And you also think about what the impact is going to be. Why does this matter? Why does it matter that there are significant delays in referrals to treatment? Well, it might be that if we can sort that out, then not only do we meet our targets better, but more importantly, we save lives. Okay, so thinking about the importance of whatever it is we're trying to do. So what's the problem? What are some of the questions that we might ask of the model to help us solve that problem? What might be the deliverables? What's going to come out of this modeling process? And why should we care about it? What's the impact? And these are the kinds of things that when you come to do your project pitches, these will be exactly the kinds of things you'll be thinking about and presenting. Another thing that you should think about when you're designing a model are what are the boundaries of the particular system that you need to model. So let's imagine that you want to model your ED, but you think, well, so you've got a problem in your emergency department, maybe you've got some delays, but you think, well, a lot of the people arrive by ambulance, so should I really be building a model of the ambulance dispatch too, because that's part of that system? The answer is you probably shouldn't, unless that's important to your question. And it can be quite difficult to try and identify where you put the boundaries on. What slice of reality are you going to create in your little computer model? Because you can't model everything. Okay, the ambulance dispatch is part of the universe. Do we create a model of the known universe as well? You have to stop somewhere. And a couple of questions that are quite helpful for helping you think about that are, what's the minimum amount of real world slice that you can model to answer your question? Because that's the whole purpose of doing this model, is to answer this question. And it can be difficult thinking about it in those terms, because there's often the misconception that the more stuff you put in, the better it'll be. Often it's the opposite that's true. Often you want something simple and elegant that can that's focused on answering a particular question. And if I do need to model other systems or other aspects of systems, can I simplify their representation in some way? So yes, it may be important that to think about the ambulance arrivals, but can I just model that as some sort of probability distribution of ambulances coming in? Do I really need to model beyond that? Does it have any impact on my particular question, or can it be simplified? Kind of going hand in hand with that, as well as, how much of the real world do I carve off and put into my computer model, is how much detail do I go into? So you might have a very low level model, for example, where you say, okay, well, in my system, the patient queues. Is it a Monday? Because if it is, then Julie will book the patient in using a red folder. If it's not, well, is it an odd numbered month? Because if it's not, then Julie will still do that. But otherwise, then John will book them in using the blue folder. But maybe none of that matters, because actually Derek's going to come along and collate them all anyway, and it makes no difference to your question. It might be. Maybe you are building a model of the red and blue folders. Goodness knows what's in them. But in reality, it's probably not going to be the case. That might be a bit too low level for what you need. But interestingly, that's very often the direction which people tend to move towards when building a model, try and capture everything, and it's usually not the right approach. Of course, you may have a very high level model as well, where you say, well, okay, patient arrives, they're triaged, seen by the doctor, they're either admitted or discharged. Now, that might be the level of model that you need for answering your particular question, but it might be too high level, and you might actually need something in between those two things. So again, ask yourself those two questions. What's the minimum level of detail you can model to answer your question? That's the purpose of you building this. And if I do need to model other systems, how can I simplify the level of detail in their representation as well? So those two questions will serve you well to sort of combat against the natural desire that we all have to chuck everything into the mix. Something we talk about in the program is that all models are wrong, but some are useful. That famous quote that you may well have heard before, and it's absolutely true. That you'll find as you're modeling, and we talk about this, that actually you're just creating a series of assumptions and simplifications that you're putting into a computer. The more of those you've got, the more wrong you might be. So you need to be thinking about that and not just thinking, well, I'll just stuff more of this stuff in there and see if that helps. And so assumption simplifications are really important aspects of model building and model design. Assumptions are basically things that we need to assume because we either don't know or we can't know their real world properties. So we might say, well, we're assuming the data we've got that we're using for this model is representative. The sample I've got is a good representation of our population. Or we might assume that there are no travel times within the clinic, or that they're trivial and it doesn't matter for this. And simplifications are things that from the real world that we're basically choosing to distill down in a simpler way, because we don't think that putting in more detail, more complexity is actually going to help. So we might say simplify our triage process and just say, well, we'll just capture the triage process as being the patient spends an amount of time with the nurse, and for that will be sufficient to answer our question. Or we might say that there are no limits to the queuing time for the MIU, something known as an infinite capacity model. And you might think, how could that possibly be useful? And we'll talk in the course about why those kinds of things can be immensely useful. So that's a little bit of an introduction to conceptual modeling and about model design. And we'll go into that in much more detail in the course. So in fact, in the very first session, we'll talk a lot about conceptual modeling and things that you can do to help you in the conceptual modeling process. But I just want to give you a bit of a flavor of that. And I'm just going to give you a little bit of a flavor now about discrete event simulation. So discrete event simulation, or DES as it's commonly known, is a very commonly used modeling approach within operational research. And it's basically a way in which we can model pathways, or more specifically queuing problems. Okay, So in health, social care and policing, we have a lot of queuing problems where people are going through a set of processes and they queue and wait for those processes. Sometimes they are physical queues, that they are literally standing outside in a queue, but in other cases it might be they're on a waiting list. That's also a queue. Okay, so there are lots and lots of queuing systems. And in a discrete event simulation, entities of some kind flow through and queue for discrete sequential processes that use resources. So they go through various different things that happen to them, and for those things to happen, it needs resource. So they go through a set of things, doesn't have to be perfectly linear, they might branch off at various different points, but one thing will happen to them, and then something else will happen to them, and then something else, and at each stage they need to wait for some resource to help this process happen. And very often in the kind of models that you'll build, those entities will be patients or people or service users, but they don't have to be. They might be blood test results. They might be phone calls on an incoming phone system. Okay, whenever you've got something that is going through a set of processes and it's then queuing, waiting for things to happen that need resource, then you've got a queuing problem. So discrete event simulation, as they typically used to model kind of process pathway kind of problems. So we talked about the example, you know, if you want to model your ED, what happens to patients once they arrive at the ED, and you can model those processes. So because of that, it's really useful as a way to ask those kind of what if questions about changes to that process. So what if we were to change the process that does this? Or what if we added in extra resource? Or what if we took away resource from this bit and put it over here? Those kinds of questions we can use discrete event simulation for. So here's an example of the kind of problem we might use a discrete event simulation for. We've got a patient arriving at the ED. They then queue for this process here, patient booked in, and this needs the resource of a receptionist. And they then queue to be triaged. That's a process and activity here, and that requires a triage nurse. And then after that, it might be that no further action is taken, they're discharged, or it might be they need to be seen by a doctor. And so a percentage of them will flow down here, and then they need to be treated, and that needs a cubicle. And then different things might happen. They might unfortunately die, or they might be discharged at that point, or they might need to be admitted to the hospital, and then that you might need a hospital bed, and so on. Okay, and depending on what you're, if you're just modeling something about the reception process, it might be that your model scope is just around this bit, and you just model that in detail. So when we talk about discrete event simulation, there are various building blocks that make up a discrete event simulation. We've talked a little bit about entities. So entities are basically the things that are flowing through these sequential processes. So patients, telephone calls, blood test results, whatever it might be. The things that are having these processes done unto them are the entities. Very often they're people, but don't fall into the trap of thinking they always have to be. Now we also have something called generators. Generators are basically the way in which our entities, whatever they are, come into the model. They come into being in our simulated system. So they represent the entry points to our bit of the system, the real world system that we've carved off and turned into a model. So it might be, in our ED, for example, that we've got a generator that represents people coming in by ambulance, and then we've got a separate generator to show people coming in who are self-presenting, because the rate at which they arrive might be different, for example. So generators are basically how you create these things, and they may be physical entry points, quite literally representing an entrance into a building, for example, but they very often they're not, and they might be just an entry into the system. So it might be, if you were just modeling the triage process, that your generator represents people coming from the reception desk, for example. We also have the concept, very important concept in discrete event simulation, of an inter-arrival time, and as the name suggests, this basically is just a way of capturing the time between entities being generated, or entities coming into the model, arriving into our model. And we'll talk more about that in the course, about how we represent those kinds of inter-arrival times. But essentially, it's a way in which we specify the rate at which they're coming in, which will drive the rest of our model. The things that are happening to these entities are we call either activities or servers, depending on, you'll hear both bandied around. If you've got any experience of discrete event simulation, you may have heard either of those or both. Either is fine, but I tend to prefer to say activities rather than servers, because I think it's easier for people to relate to. But they're basically the things that are happening to the entity. So the triage activity, the treatment activity, the water vision activity, whatever it is, these things that they're queuing for and for which we need resources. And with each activity or server, we have an activity or server time. And that basically represents the amount of time it takes for an activity to happen to an entity. So how long this particular patient is going to spend with a triage nurse, for example, how long it's going to take for this phone call with an advisor, or whatever it may be. And again, in the course, we'll show you how we use things called distributions to be able to capture the real world variability that's so important, and make sure that that's captured in our model, because not everybody comes in and spends exactly 5 minutes with a nurse, for example. The resources, as I say, they're the things that are required for the activities to take place, and they might be shared between activities, because very often, a nurse doesn't just do triage, they might be doing other things at the same time as well. We may need to capture that. Similar with doctors, or beds might be used for other types of patients that we're not modeling. But whatever resources are needed for these activities to happen, we need to model that in some way. Queues very obviously are where our entities are held until an activity has both the capacity and the required resources to begin. Because if we think about it, if somebody's queuing for something to happen, they're waiting for a triage, we need basically the nurse to be available and to be free to see them. It might be that in some activities, you've got a capacity, you can see a couple of people at a time, but in many cases, it'll just be sort of one in, one out. And so both of those things need to hold true if you're for somebody to leave the queue in order to join the activity. And much as we had generators, ways in which people can come into a system, the opposite of a generator in discrete event simulation is a sink. And that's basically how they leave the model. So they come in via generators, they're brought into being, we generate them, they flow off through our system, and then they leave the model. So going back to the example that we talked about here, our generator here was a patient arriving at ED. So we've got a single generator, we've got queues for each of these activities, and then we've got various sinks. So here's a sink where they're triaged and then no further action is taken. They leave our model. But we may also have sinks where it's a little bit less obvious. So it might be that we don't model, if we're just modeling the ED bit, we might not need to model this bit. So we might just say when they're admitted to hospital, that's a sink. They leave our model. They're not leaving our hospital, but they're leaving the scope of our model. And that's where our sink will be. Now, probably not a great example of ED, because as many of you will know, this bit is fundamentally important to this bit in the ED hospital system. But you can, I'm sure, imagine scenarios where it isn't. And in fact, the scope of your model would be cut off. The particular slice of real world would be cut off separately there. So here, in our case, our inter-arrival times would be the rate at which people are arriving at the ED. Here we've just got a single generator. Again, if it was ED in reality, you'd probably have multiple different rates, because the rate at which people are arriving by ambulance would differ likely to the rate at which they're arriving by self-presenting. Our entities are patients, and our activity times are the time being spent booked in, the time being spent triaged, the time being spent being treated, time being spent in the ward. And as I say, that would differ for each patient, but we will use distributions to capture that variability. So we'll say, well, on average, patients spend about 3 minutes being booked in, but some patients might take a very long time, some patients might take a short time, and we'll show you in the course how you accommodate for that. When we're talking about queuing as well, it's very important to think about how people queue. So there are various concepts in queuing, and here are three very important ones that you will likely come across in your own systems, known as reneging, bulking, and jockeying, because not all queues run as planned. So you might have different queuing policies for a start. So the default queuing policy in SimPy, for example, is first in, first out. People queue and then they're seen in the order in which they queue. But we'll also show you in the course how you have different queuing policies, because of course in some cases, particularly in healthcare systems, you might say, well, yes, we do that, but then if a higher priority patient comes in, they will jump the queue. And there's ways you can do that in a discrete event simulation to assign priorities to patients as well, or even to have, you know, completely separate policies like last in first out or whatever it might be. You can have all sorts of policies. But even aside from that, it may be the case that a queue doesn't run as planned, okay? Because very often you're dealing with people as your entities, and people have a mind of their own, and they do things that you don't necessarily plan for or want them to, and you may need to accommodate for that. So you might have people who are that they stop waiting, they're waiting too long, or they decide to switch queues, or they never join the queue in the first place. So let's imagine for a moment that we have this wonderful event, an audience with Dan Chalk. Now I couldn't possibly have a slide big enough that would capture the length of queue for such an event, but let's just imagine that it's as short as indicated on here. Let's imagine they're queuing for the box office. Now we might have reneging behavior, where reneging basically says, I joined the queue, I'm not waiting any longer, this is ridiculous, I'm leaving. That's basically reneging. So it's a person or an entity that's not willing to wait any longer. But of course, as I said, entities don't have to be people. So if your entities were, for example, test samples, might be the test sample is no longer viable because it's taken too long to be tested or to be analysed, and so therefore it's no longer viable and it has to leave the queue. So there's all sorts of ways in which, you know, entities can renege from a queue. I can't imagine anybody ever reneging from such an event here, but you know, let's stretch our imaginations a little. Bulking refers to basically an entity that looks at the length of the queue and says, I'm not queuing there. That's way too long. I'm not even going to join the queue in the first place because it's so long, or because, you know, the capacity is insufficient. So it might be that they see a very long queue and they think I'm not joining, or they look at the waiting room and see there's no capacity and say, I'll just have to come back tomorrow, or whatever it may be. And then there's also jockeying, which basically is where somebody's joined a queue, but then they look at the queue over to the right and they say, oh, well, that's a shorter queue, maybe I'll queue there. And so they seem to be getting through people quicker. We've probably all done that, or seen it at least, at the supermarkets where you're switching tills. That's jockeying. So the next time you go to the supermarket, you can think, oh, I'm jockeying, or I'm seeing somebody else jockeying, and that's exactly what they're doing. And that's queuing to it, basically. Okay, I've talked enough. That was a bit of a wild introduction to discrete event simulation and conceptual modelling. And as I say, in the course, we'll go into much more detail about both of those things. You'll learn much more about discrete event simulation and, of course, crucially, how to build them. So you'll get some hands-on time to build this stuff in Python as well. So what I'm going to do now is I'm going to split you into groups in breakout rooms, and I'm going to hopefully this will work. I'm going to randomly basically just allocate you across various groups. So what I want you to do, and overrun slightly, so I'm going to give you about half an hour, so to about 25 past, and then we'll just come back for 5 minutes at the end. Split you out into groups. I want you to come up with some ideas in your group about real-world queuing systems. They might be, you know, work-related systems in your own organization, but they don't have to be. Might be systems that you encounter in the wider world too. So come up with some ideas about some real-world queuing systems, and then what I want you to do is to pick one of those and come up with one or more what-if questions. What are some questions you might want, if you were building a model of that system, what are some questions you might want to ask to help address a potential problem, whether real world or fictional? And then I want you to come up with a very brief design for a discrete event simulation of your chosen system that would help you answer those what-if questions. So think about the kind of scope that we talked about. You know, how much of the real world would you slice off to answer that question or those questions? How much detail what's the level of detail you would implement for that particular model? And basically, if your model design, you should have either a drawing, or you could, however you want to do it. If somebody wants to share their screen, I'll enable screen sharing for everyone in a moment in your group. So I'd have one person sort of sharing a screen, somehow get this information down. You don't have to draw it if you don't want to. Can I just check everyone can still hear me? Yeah.
Yes.
Yeah, brilliant. Thank you.
Yes, yeah, we can hear you.
My Zoom started to go. It's quite funny, Kath. Your face has now appeared over my head. I think that's probably an improvement, but nonetheless, it was quite worrying for me for a moment. But I seem to be returned to normal now. Great. Okay, Zoom has a habit of just randomly crashing on me. That's why I thought I'd better check. So basically, yeah, come up with a design. Think about what your generators would be, what your processes might be, your flows, your queues, the resources and the sinks, all that kind of stuff we just talked about, and what your inter-arrival times you might want to capture. You don't need the data. You don't need to think what the times would actually be, but what sort of inter-arrival times would you capture? So for the ED, you might have say, well, we'll need inter-arrival times for people arriving by ambulance or people arriving on foot, etc. So I'm going to give you about half an hour. So we'll bring you back about 25 past, and I will pick on a group, at least one group, to share what they've been doing. So nominate someone who is happy to just talk very briefly about what they've come up with. As I say, I will put in the chat a link to the slides, so you can refer back to the slides. But basically, do something like this, where you just build a little very quick, simple indication of what your system might look like, and what your inter-arrival times you need to capture, what are the entities that you're modeling, what activity times you need, what are the queues, what are the processes, etc. So pick something fairly simple, and have a bit of a chat first about what some real-world queuing systems might look like. Okay, what I'll do, I'll stop sharing at that point, and I will put a link into chat now. If you'll let me copy it, which is not for some reason. Okay. Let's put this in the chat. And then what I'll do, I will set up the breakout rooms. I'll set up some, I'm hoping this works. I will set up some new breakout rooms and then randomly allocate them. So we've got about 100 of you left. So I'll probably, rooms about 10 each, I think would work. So I'll set up 10 rooms and then just randomly allocate each of rooms. So I will do that now. Recreate some rooms on 10. And don't worry, I'm going to stop the recording, so you have no fear of being on camera or anything after this point and it going on YouTube, so don't worry about that. Okay, brilliant. I will now open the rooms. Nominate who would essentially be the person that is your sort of key project manager, point of contact. They'd be the person that you'd be liaising with the most, but obviously the project team will be working on the project. Those project teams either assemble at the stage at which people are putting together ideas. So some people they've been talking and they think, oh, actually these are common issues. I think we could put together a project, a collaborative project to sort that out, as we've had quite a lot of those this year. Or it might be that their project didn't get through, but they'd like to join another one. In most cases now, I think people tend to sort of form into project teams quite early. But in terms of the mentoring, yeah, so you would be, we'd need you to mentor a project. You would be, if you've got capacity and willing, you're more than welcome to mentor more than one. But certainly for our external mentors, we only expect you to mentor one. We do mentor multiple projects each within the team.
Okay, great.
Well, is that good? Fantastic, thank you. Okay, I have no idea in the order,
yeah, great. Thank you.
Top, but I will just go through in the order I can see. There's a Catherine. I can see. I think your hand went up a while ago.
Hi, thank you very much. My name is Catherine and I'm an intel analyst with the police, and I just wondered whether or not the interest from the police is sort of increasing, because I know a lot of it seems to be quite health orientated. Just how that kind of like applies in how it applies into the police, and whether or not you've got any contacts of people who are currently doing it in terms of their programs they're working on or anything. That would be really helpful for me.
Yeah,
just
sure.
to see how I can, because I'm on a regional basis, and it's just to see how that I can essentially pitch it to my organization to be able to say, yes, this would be good for us, because I think it would be great, both personally and professionally. But it's just how I can take it back to my organisation, really.
Yeah, no, of course. So, so it's a good question. So the policing aspect came in to HSMA and to the wider team much later. So obviously we are specialists in health service research, and that's what the ARC was set up to do. That's what our team was set up to do, and that's what we do in terms of our project work. But we did get we got a small amount of funding in a couple of years ago now to do a bit of a pilot. We got something called a policing lab here at Exeter that basically works in partnership with Devon and Cornwall Police, and there was interest. One of my colleagues actually had long had an interest in police service research as applied to sort of the wider health system, and thought, well, can we make this HSMA thing work for the police? So we did actually initially what was a separate pilot we called the Police Service Modelling Associates program, and we had 10 policing associates. 5 were from Devon and Cornwall Police, our partners, but we also had some people from Avon and Somerset, Dorset, College of Policing, a couple other places as well. And basically it was a bit of a pilot to see if this would work. What was interesting about that was that, well, 2 things. The first was that we started in January 2020, so you can imagine what happened shortly after starting. But the second was that we identified that a lot of the problems in policing are very, very similar to the problems that are faced in health. You know, a lot of the same types of issues, it's just different things. And so we recognised actually that these methods work very well. Now, because of the pandemic onset, we stopped the pilot, put it on pause because we needed to work out how this would continue. But then when we launched HSMA 3 in the October of 2020, we actually launched the PSMA program back running as part of that. And so we had this idea that we thought, well, actually there's a lot of benefit from bringing together health and social care people with policing people working together. And so we did that, and that was really successful. So we had the 10 initial policing associates. They did some work, and I'll put a link in to the website. So this is the HSMA website that I linked to earlier, but if you click onto that and go into our projects and associates and then HSMA projects, some of the initial PSMA projects from HSMA 3 are on there. One was a fantastic project with Devon and Cornwall Police that was looking at, which I mentioned right at the start of this morning, using network analysis to try and identify connections between people where people might be at a risk of being drawn into criminal activity, and that's been really successful. And there was also a project with Avon and Somerset Constabulary. It was amazing. So he's one of our mentors on the current program now. I don't think I've ever mentored somebody less. He just went off and did this wonderful stuff. He basically designed a tool that uses AI to automatically identify the sentiment of every tweet to every police force in the country, to identify whether they're positive or negative and work out what people are talking about positively and negatively, and then design this entire dashboard. It's absolutely incredible to see. And if you want to see a bit more about that, there are I can share links to our previous the presentation event where he presented that, and the Devon and Cornwall Police people who presented that their work at that one as well. That's on our YouTube channel, and you can find out a bit more about that. This year we've got a couple of other projects. So there's one that's looking at firearms criminality in I'm just dialing all the details. So they're looking at so there's a kind of a bit of a they're working with health service and also local authority people as well. So that's Northwest England, just dialed that up. That's being led by some people in the National Crime Agency. We've got somebody from Devon County Council who's involved, also somebody from Devon and Cornwall Police, and that's being mentored by the chap who did the Twitter stuff as well. And I'm just scrolling through to see if we've got any others this year. There were a couple of projects that that we didn't take on because of ethical issues, but they sort of withdrew themselves after the ethics training, interestingly, that's because they thought there might be issues. So there are there's 2 previous examples and 1 current example that I can point you towards for that. I can't share their contact details, but I can get in contact with them and ask them to contact you if that's helpful, if you'd like to speak with them more. And obviously, if you do get onto the program, you'll be on our Slack workspace where everybody who's been on the program is also there as well. But if you have a look on the website initially, that's got some information about their projects, and have a look at their the YouTube channel for the HSMA 3 presentation event from last year, because they presented on that work as well. So I think in terms of the policing work, that is expanding. Obviously, it's our primary focus has been naturally health and social care research, because we are a health and social care research team. But there is very much increasing levels of interest from the police. I think we try to steer people towards thinking about system level issues, so stuff that, like the firearms criminality, like the stuff around the safeguarding and getting drawn into criminal activity, that has a kind of health aspect to it as well, because I think that helps us. You know, we are funded as health researchers, but it helps us to bring in that sort of policing aspect to it as well. But we have also done, you know, just purely police projects as well, like the Twitter stuff.
That's brilliant. Thank you so much. That's really helpful. Yeah, any contacts are good. And yeah, I can see where you can get a lot of like collaborative working and with that kind of thing as well. So yeah, really happy with that. Thank you.
Brilliant. No problem at all. Okay, I'll go in the order in which I can see them. So apologies if you've had your hand up longer. Tony next.
Yep. Can you hear me okay? Yeah, I'm trying to start my video, but it doesn't want to start. Okay, I apologize for that. Thanks for that. That was really, really useful introduction. I may have missed this earlier because I had to drop out of the meeting, so I apologize. I understand that we use operational research and we use like Python to create models and do analysis. Does the course then allow us to operationalize that insight by creating things like apps or web pages that people, so I work in a hospital, so that people, let's say in an emergency department, could then use the insight that analytical engines generated to then, you know, kind of help them run the department?
Yes, absolutely. So a couple of things that we covered in the course, in some of our bonus materials, and something that a few of our current HSMAs are doing. They're using various things. One of them, which is Streamlit, where they can put Python apps up online, so that people can play with an app. We've got people doing the same with some of the R stuff, using R Shiny and R packages. So yeah, and something that we absolutely push and encourage people to do on the program is to, because, you know, obviously we want people to, at the very least, to share what they've done. But if there are things where they can, you know, make something that people can interact with, then even better. And a number of in fact, most of the current projects, I believe, are doing that in terms of. So and we will. One of the things that we'll put in the new masterclasses that we're bringing in for this program will be stuff around that as well, expanding that out to help people and support people to do that.
Yeah, that's a really exciting bit. Thank you. That's great.
No problem at all. Seagal?
Yeah, sorry, oh, great. Don't know that I was the next in line, but thank you.
Possibly not. I'm having to go random.
Question, how many projects get selected to go forward? So just trying to ascertain how likely it is that there will be at least one that I will be really interested in, because we're talking about quite a huge amount of effort going into someone else's, well, I know it's not exactly someone else's project, but so what exactly is?
Yeah, so this year we'll be taking on 20 projects. It might be more than that. So the thing that constrains us is basically the mentoring capacity, because we're a small team, and now the rest of the team are dedicated to other things. The HSMA team, as I say, is currently me, and there's only so many I can mentor whilst also running the program and doing everything else. So part of the reason we brought in the trainee mentor scheme was to help improve that capacity. So we've got, as I say, earmarked 10 places available. We actually have more. I think we had 11 last year who came onto the scheme. If we get more mentors, that 10 isn't a fixed limit. So, you know, if we get 50 people that want to come on and be mentors, we could, and they're all suitable, then we could take on another 50 projects. It's flexible. It should be at least 20, but we might be able to take on more, depending on what the capacity is like. And also, as they were trying to build up a dedicated HSMA team, we'll have somebody starting in September, and depending on how we can recruit in the next month or so, we might be able to take on more internally as well. So it should be at least 20. So it's, you know, it's a fairly, I mean, if we take on 100, so obviously it's about 1 in 5, but what you'll find is that people will tend to start to collaborate even before they put in projects anyway, because a lot of them do now. They group together on projects because they're trying to tackle something, a common issue, so that we don't tend to get 100 pitches. And, you know, some people find it isn't for them, and we'll pull out the program. Not a huge amount, but we do get a few. I can't remember how many pitches we had last time, but it wasn't, so we took on 80 associates. I think might have been about 40 or 50 projects, pitches, something like that. Yeah, it probably won't be the full amount. So there's a fairly decent chance that your project will get selected. And we also like to try and take on as much as possible. And sometimes we identify that there are projects that are very similar, and we suggest that you group together because actually you're tackling the same thing, just from different perspectives. So there's also that as well. Yeah, there's a pretty good chance your project, you know, as long as it meets the criteria, we think it's doable and impactful, would get selected.
Fabulous, thank you.
Okay, we've got Philip next.
Yeah, hi. Thanks very much. I found today extremely informative, very, very helpful. I work in the NHS. I have a dual role. So half the week I'm a clinical auditor. The other half I'm a NICE facilitator. I have absolutely no experience whatsoever in coding or in Python or R or SQL, because my 2 job roles, and the NICE facilitator is only a very recent one. They just don't require me to use those types of software. So I'm a bit nervous about not getting through, first of all, because of that lack of experience. However, as a clinical auditor, I know that it's only a job role within the NHS. The Chartered Institute of Accredited Auditors don't recognise it as an official profession. There is no official qualification. So I'm getting a bit nervous. I'll be 52 in a couple of months. Our trust is going through a complete restructuring. People are very nervous about the jobs. I very much enjoy the data analysis side of things. I would never call myself a pure data analyst, never in a million years. However, I do use various techniques that some of the other team don't use in order to analyze it and basically to present it in a slightly different way. So the traditional format is, and please don't shoot me down for saying this, is using pie charts. I know how much they're loved or hated. So I use various different things. I use the likes of the 2-tail test. If I'm comparing and contrasting, if it's like a monthly or a very regular occurring audit, I'll use the coefficient R as well to help determine whether or not there's been an increase or a decrease from the previous month. I've also built a number of different dashboards from monthly ones, so I could do, and I did one for a service where we've got 3 district general hospitals that are not under Merseycare, but if a patient is admitted and they get referred into our mental health service, so it was looking at that. We had to put a hold on it because of COVID, so I did a compare and contrast before, 6 months before, and 6 months during COVID, and I built myself a dashboard, and it was really, really well received. So this is an area that I'm, in terms of data analysis, that I'm certainly putting a lot of time and effort into. Maybe I might need to completely change over. I've never written anything like a model. I'd be completely wearing L plates from every standpoint, and I want what I didn't want to do is obviously to draw more help away from other people that are on the course. So I just wanted to basically give a very quick synopsis of my background and to whether or not I would be realistically an ideal candidate to come on there, because I don't see that I would be able to use that in my normal role moving forward. And so I don't know whether or not, given the way the trust is going, whether or not they'd support me for 15 months. That being the case, can I do it as an extracurricular thing? Because I'm very keen on this, and I see it as an additional and very powerful string to my bow, because I'm already starting to look around.
So so it's a good question. So I would say, please don't worry about the fact that you haven't done any coding or modeling before. Whilst we do get people on the course who have done coding to various degrees, a lot of people haven't, and we've taken through a lot of people, and our programming and our whole training is based on the assumption that you haven't coded before, but if you have, then that's also okay. So we take it through from first principles of coding, so that won't be an issue. You may find a sort of steeper learning curve at the start, but hopefully with the new the new sort of 6-month structure, that you'll have a bit more time to get that sort of bedded in, and support with the coding clubs, etc. as well. So I wouldn't let that be a problem. And it sounds like you've done some data sciencey stuff. You've got an interest in that, and analytical stuff, and I think that would be okay for that. The bigger concern would be around the organizational support, and that's primarily because with the program is kind of set up, so it is a training program, but it is set up as a training program that will support people to undertake projects that make a real difference. And so if you haven't got that organizational support, that can make things trickier, because obviously then you haven't necessarily got that support to run a project. If there would still be agreement for you to undertake project work for for another project, that potentially could work. I mean, it's difficult to say. And obviously it's difficult for you to say, because things that sound a bit up in the air, so you don't know sort of necessarily the direction in which things are going.
Yeah, well, the trust are in the middle of a 45-day consultation period, which will end the end of next month, and so basically August we get to find out if we still got our jobs, if our job roles are still going to be the same. There's been a number of people, obviously from a very high level, who add-ons to their role have been either completely taken off them or subdivided with others, and that seems to be filtering down the strategic sort of framework.
Yeah, okay. So what I'd suggest you do, because obviously I'm conscious of sort of application timescales and things like that, so sure. I would apply, because there's no harm in applying. That by the time that the applications decisions are made, hopefully you'll know a little bit more. If you don't make it onto this round of the program, you would still be put on reserve for this round, or potentially you could apply again next year. Or if the situation updates and becomes clearer, and you then realize that it's not going to work, then you could tell us if you were picked onto the program. So for the moment I would apply. And then you can always sort of cross that bridge when you come to it a bit further down the line. But at the moment, I'd certainly apply. If it does come to the fact that you can't do the program, or you don't come to the program, the other thing to say is that you could either, as I apply again for HSMA 6, or in the meantime, obviously all our training will be put up online as well, so you can follow along with all the materials and all the lectures. You just wouldn't get the support with the project, but that might be enough for you for the moment, so it might help in that way. But at the moment, I'd say apply and see what that will at least buy some time for you as well, I think. So
for sure. Thank you very much. It's been a great workshop. I've really enjoyed it.
No problem at all. Glad you've enjoyed it.
Thanks a lot. Have a good day.
Few more hands. I'll see if I can get through at least a few of them. So Mubash, is it Mubash?
It's Mubashra, but no worries. So my question was, during the first 6 months of the course, when it's the training period, do we do smaller scale projects or assignments in groups that will kind of let us practice the concepts that we're being taught?
Yes, so you basically get so within the lectures there you'll have various group exercises that you'll do. So in the discrete event simulation, some of the exercises will be that you will build, you'll be given a problem that, here's a model, you need to create a discrete event simulation in SimPy, and you work on that as a group. In the agent-based simulation stuff, you'll so some of the modules you actually get to design something as well as you come up with something and then create it using what you've learned. So yes, you'll get lots of practice doing that, lots and lots of that. And also in the optional coding club sessions, you'll set a sort of task, and then as a group you'll all work on using the coding skills that you've just gained and the stuff we've just covered in the program to try and have a go at building something, basically. So yeah, there'll be lots of opportunity to do practical hands-on stuff to practice what you've just been taught.
Thank you. Just going on that, is our practice coding time, is that kind of built into that one day of the week? So for the training phase, you'll have a day a week, and that will be as I say, apart from there are 2 weeks, and if you look at the dates, there'll be 2 weeks in October where there are 2 sessions in a week. That only happens in October. One is just a half-day session on the Thursday. The other is a full-day session on the Thursday. Most sessions, training sessions, will be on the Tuesday. The training sessions, most of them are full-day sessions, so they start from 9:30. You'll get a session in the morning. So each of the sessions is basically 3 hours. So you'll have a 9:30 to 12:30, and then a 1:30 to 4:30. So basically most of the day will be for that. So anything that you practice outside of that would be kind of in addition. I mean, you could do it on the same day, but you might be a bit exhausted by the end. The coding club sessions, which are optional, they'll be once a month. I think they mostly fall on Wednesdays, and they're just little 2-hour sessions that are optional for people. We do advise generally, and in the information for applicants, it will say that really to get the most out of the course, you do need to be probably putting in some time outside of the main course. That might be that you can get some more time protected, or it might be that it has to be in your own time, and it will vary depending on your A, what your previous experience is, and B, how quickly you can pick this stuff up. One thing that a lot of groups have done in the past that seems to work really well is they might arrange a time to get together in their peer support group and just have a sort of a teleconference chat about what they've learned in the last couple of weeks or whatever, and that can help. So it's almost like a revision session, if you like. So that can be quite useful. But however people like to do it, the requirement from our perspective is to attend to dedicate a day a week, but you might need, depending on how well you pick stuff up, you might need a bit more time outside of that. Okay, thank you so much. Really, really helpful morning.
No problem. Thank you. So is it, apologies, is it Shan or Scam?
Hi, it's Shan. Thank you for today. Just a quick question from me. I just want to ask if you guys go into the maths or the stats behind the concepts that are taught.
Not very much, I'll be honest. So I and most of the team are not statisticians or mathematicians. Most of us are computer scientists. I'm a computer scientist. So there is a bit of that, and we usually signpost you if you are interested in diving deeper into that, where you can find out more about that. So particularly for some of the machine learning stuff, we get into logistic regression, all that kind of stuff, that we will cover a little bit of that. But don't worry if that isn't your thing, then don't worry about it, because it's by no means essential. So it's there if you want it, but we mainly direct people to other locations. The whole course really is designed to be practical and applied.
So we teach you what you need to know. So when we talk about the machine learning algorithms, we talk about what they're doing and how they're working, but less about sort of the mathematics behind it, if you like, and more about, you know, practically what that means and then how you would then implement that. But we can guide people to the maths if they're interested in that as well.
Yeah, okay, thank you very much.
No problem. So Rob.
Hi Dan. Yeah, thanks for a really great morning. Appreciate all the information, really useful, really exciting stuff. I've got a really basic question, and apologies if I've missed the answer to this. Is there a formal qualification at the end of the program?
So no, there isn't at the moment. It is something we are looking into though. So basically we're trying to explore whether we can get the program accredited, which will have some sort of you know, formal qualification. I can't guarantee that. All I will say is that we are looking into options, and in doing so, we are trying to look at options that would allow us to apply that retrospectively as well for people that have been on the program.
Okay, that's really useful.
But again, I couldn't guarantee it because I have no idea what we're going to be able to do at the moment. So I'd go in with the expectation that it won't be, but that it could be.
Okay, appreciate it.
No
Thanks.
problem. And then I think we've just got one last hand. Is it Dimitris?
Oh, hi. Yes, thank you. So my question is in regards to the programming language. Sorry, I missed the first hour of this call. So, but I've heard people talking about Python later on. Is Python the language of choice? And if that's the case, is there an alternative option for people who are already comfortable with another language like R to perhaps, you know, get access to algorithms written in R instead of Python?
Okay, so Python is the main language that we use on the course, mainly because virtually all of us in the team are Python based. We do have a couple of people that do it of R. We do teach R on the course, but it is quite limited compared to Python. We have had people on the program who have, for their project work, they feel more comfortable using R, so they've tended to switch to R for that. But we can't, because of the scale of the stuff we've got, we can't do anything more than possibly signpost you to reading that you could have a look at, you know, the equivalent in R. So no, we would for so for example, the discrete event simulation is based around the Python package SymPy, and there are packages in R Simmer and stuff like that that are similar to that, but we don't teach that because of the scale of the course. We can't, unfortunately. We could signpost people, but we can only support in the training. We can only sort of provide materials for the stuff we're teaching. But of course, during the project phase, people are, you know, you can go off and use whatever you like, as long as it's, you know, it's something that we've taught in the course in terms of the methods. Then it doesn't matter what, you know, if people prefer to use R and they want to use R Simmer, that's absolutely fine. So we haven't got a problem with that. But just be aware that that would then require a mentor that can advise you on that. Which in the team is less at the moment, but the in the training mentor scheme, we will have people coming on, I suspect, who've got our experience as well.
Yeah, thanks very much.
No problem at all. I think we've overrun slightly, but there was one last hand. I can take one last question. Is it GK?
Yeah, my name is Saeed.
Oh, right, okay. Sorry. With the Zoom name,
that's,
you never know.
Right. My name is Gal Saeed and I work for Arden and Jim. And I work on system dynamics before. I work with a team and I've done some operational research modules from one of the unions in Scotland. And I know quite a bit about discrete event simulation. And my question is, like, somebody asked that question earlier on, whether you're going to cover the statistics behind the modeling as well, like inter-arrival time and you know, or the arrival time of the patients or the customers or whatever. And you said like, we don't. So, but those are the things like the distribution, like Poisson distribution or exponential distribution, to model the and account for the variation of the arrival of the customer is very important.
Yes, sorry, there might be some confusion about that. Sorry, I wasn't talking about that. So yes, we absolutely do talk about what distributions are, the kinds of distributions you might want to use for your models, how to fit distributions. So we do that side of things. Sorry, I was thinking more in terms of the some of the sort of the heavy maths behind some of the machine learning algorithms and that, which we don't cover that in detail in the course because it's more applied. So anything where it's relevant to the so for the distribution, etc., absolutely, yes, you could. In fact, the very first session of the course, we talk about why distributions are so fundamental to modelling. So that yes, we do cover that kind of thing.
Another question, like, is like, how do you validate the, like, if somebody developed a model, how do you validate the models in absence of the real data? Do you use like synthetic data to validate it, like just to test that the model produced the results it is supposed to be? Like,
so if you're talking about the HSMA projects, we don't. So
right.
One thing that we're very clear about right from the start of HSMA is that these are not our projects. So we will support you and we will give you advice, but the ownership of the project remains completely with the HSMA and their organisation. So we don't get involved in that. We give them advice and talk to them about how they can validate their models, and you know, that's part of the course as well. And we'll give them advice through the mentoring, but we don't sort of quality assure their stuff, if you like. Other than, you know, we are part of the conversation, but we are not part of the project team, and that's quite important for the program. Now it might be so if some of the projects turn into papers, publications, then that's been co-authored by the mentor, for example, then at that point, then yes, they would, because they would then be essentially putting their name to this research, so they would then become more involved in the details of the model and how that was being validated and checking over that stuff, but otherwise no. And so one thing we make clear at the start of the HSMA program is the mentoring relationship isn't kind of one where, you know, people send us lots of code and we check it over. We don't do that. That tends to be why people appreciate working in project teams where they're sort of doing that with each other. But yeah, it's not that kind of relationship. We support people to manage projects and provide our advice and our experience, but they are your projects essentially, and that means you get all the glory from them as well.
Thank you, Daniel. You've been very helpful. Thank you.
No problem at all. Okay, I think that's all the hands. So thank you to the 25 of you that stayed to the bitter end. As I say, thank you very much for coming along today. Once the applications go out, I hope you'll strongly consider applying for the program, and I look forward to seeing some, if not all of you, come October. If you keep an eye out as well, as they do come along to the event in September, where we'll be presenting, so that'll be another virtual event where the current HSMAs will be presenting on their work. And do use the HSMA resource site. There's lots of information on there to help you answer any questions. But if you do have anything that hasn't been answered on there or hasn't been answered today, then do get hold of us and we'll do our best to help. Brilliant. I will stop there. Thank you very much, everyone, and thank you for coming today. Goodbye.
Thanks, Daniel.
anyone still there?
I'm still here, Dan. Should I stop the recorder?
Oh yes, yes, I forgot that.